Yeah.
Hi guys.
Class.
For those of you talking about Holy Communion,
Stop shouting.
I will soon mute everybody. Don't worry. I will soon mute everybody. But for those of you,
Yes, sir, it's good like that.
Good evening, sir.
You have to manage the time, please. For those of you talking about Holy Communion, this is my bread. I hope you remember.
Sir, what's this one now? Sir, we cannot eat this thing.
So, please, while they are singing, this is my body. Just get the communion alongside. You understand? We just have to get this thing done. I know that we are meeting next week, right? Okay. So I won't even mute anybody again. If I hear noise again, I'll just mute everybody's bounce. No wala, nothing. Okay, so where are we? Okay, no. I think okay, guys, are we together? Guys, are you with me? Guys, are you with me? Let me know if you are there.
This man have started.
Okay, so we are.
Yeah,
This man has
example K.
and I hear. Okay.
I'm fine.
Some of you get my touching my network so that I will be able to take this class. Let me take this class.
Nothing.
Not your phone.
Okay, I know what to do. Okay, I think everybody has spoken now, so no need to mute you. You do not cooperate, I will mute everybody. So I want to pick it from this example 3. I just want to pick it from this part. I will re-explain this part because I think that's where we stopped the other time. I hope you guys know that I'm also a reading member, so please don't be too religious than others. Please create things. Okay. So now look at it. This is where we were. Let me quickly talk about this before we go to the next class. Next example. Y is equal to 9x plus 1. Y is equal to sin 2x plus 1. Manage participants, mute all. Fornication, copulation, making the two. Read themselves, no. Okay, other participants. Okay, other participants to rename themselves. No. Good. All right, so nobody talks again. Are we together now? It's fine. You can send through chat. Can talk to me through chat. I want to manage people's time. Don't do attendance now. If you don't want me to miss anybody's question, please don't write your name now. If you don't want me to miss anybody's question, don't write your name. Only question now, please. Only question now, please. Okay. So we have y is equal to sine 2x plus 1. You add the y here, you add the x here. When you multiply 2 by x, you have 2x, you have 2 dx, then you have this, your normal 1. Then you bring your y here, and like we said, this serve as your a, and this serve as your b. Recall that sine a minus sine, recall that sine a minus sine b itself. This is the formula for sine a minus sine b. We already know this to be our a, and this to be our b. Are we together? So now just insert your a. What is your a? 2x plus 2 dx plus 1. That's what we have here. This minus is what you have here. What is your b? 2x minus 1. You have it there over these 2. Now the same thing with cos here. Your a comes in and your b comes in over 2. Can we try to resolve the issue of minus that is here? So you have minus times 2x, it gives you minus 2x. Minus times 1 gives you minus times 1 give you minus 1. So when you have this, minus 1 will cancel plus 1, minus 2x will cancel 2x, so that you can have something like 2 dx over 2. Then this one will just continue that way. Are we together, guys? if you are getting me, I'd just like you to say I through chat box. If you are getting me, say I through chat box. So you have dy is equal to 2 sine 2 dx over 2. Now, because that one is actually over 2, we have to break them. It's still the same thing, 4x over 2, 2 over 2, and 2 dx over 2. If you use 2 here, you have 2x, you have 1 here, then you have the x here. Is that fine? Now, apply the x to all sides now. So you have the x here, you have the x here. The same ideology of knowing, recall that sine x over x as x tends to 0, recall that will give you 1. So if that will give you 1, consider that idea from what we have here, sine dx over dx. So that will give you 1. That's how we have this one, since lim sine dx tends to 1. So that's why we have sine dx over dx as dx tends to 0 is equal to 1. So this dx also will turn to 0. That's why you now have these 2. This is 1. You have 1. Multiply by cos. Your 2x is there. Your 1 is there. Then your dx turns to 0. That's how you have 0. Then your final answer is now dy over dx to be equal to 2 times 1, 2. 2 cos 2x plus 1. That's the final answer. So when you differentiate sine 2x plus 1, your final answer will be what? 2 cos 2x plus 1. That will be your final answer. Can we check the next example? The next example is differentiate exponential x. Differentiate exponential x. We want to differentiate e raised by x. That's exponential x, right? Are we together, guys? That's what we want to differentiate. Let me be sure you guys are able to get what I was explaining. Okay, OJ Treasure. Okay, I'm coming, OJ Treasure. You ask your question before I go further. Let me give OJ Treasure room to ask a question. She's been complaining that we didn't allow her. OJ Treasure. Okay, Treasure, are you there? You can talk now.
Yes, sir.
Hello, Treasure.
Yes, sir, I'm hearing you, sir.
Hello, Treasure.
Sir, I can hear you.
Hello, Treasure.
I can hear you, sir. I can hear you, sir.
Okay, good. Ask your question, please.
Yes. The previous example of 1 and 2, you made an illustration with the whiteboard that we should split it, something like 2ab over c, something like that. Why didn't we do that here also?
Don't forget, this one is talking about figures. This is not purely cost. This is not purely sine. You are already having something like 2x plus 1 here. You understand the idea? The reason we did that, let me try and see if I can do that. There's something like this. Are you with me? The
Yes,
whole
sir.
idea is we want to be able to remove dx over 2. We want to turn sine dx over 2 to 1. That's the whole idea. That's why we are trying to find everything to make dx here turn to dx over 2 so that it can give us 1. OJ Treasure,
Okay,
you
sir.
get that now?
Yes, sir. Yes, sir.
Any other person with question? Raise up your hand. Let me see here. Anybody with question? Okay, Ogungbe. Okay, let me allow Ogungbe too. Ogungbe too. Yeah, those are people that vexed the last time. Ogungbe. Yeah. Ogungbe Damlola, right? Ogungbe, Pelumi, are you there? You can speak up now. Pelumi. Ogungbe is not there. This is Ogundele, sorry. Ogungbe, what are you using? I don't know what you are using. We couldn't get Ogungbe, unfortunately. Maybe her name is not direct. Ogungbe, can you send a message so that I can be sure of your name? Okay, she's currently not active. Okay, good. So let's just continue. Thank God all of you know that we check out for Ogungbe. So now example 4, we want to differentiate e raised to power x. The same idea goes for what we have been doing. So now pick it from the earlier example. You add your dy, Abby, and you add your dx. Having added that, then you bring in your y to the other end so that you can have e raised to power x plus dx minus e raised to power x. Now this is where some of you may have challenge. Please listen carefully here. Listen carefully here. when you have something like this, you know, you can rewrite this one as e raised to power x dot e raised to power dx. You know, I taught you this under functions. We taught this under indices, all these things that you can rewrite this as e raised to power x. And so if you are trying to bring them together, it will not turn to plus. You remember the power. Now, if you have, so from this, we have this and we have this. Now, somebody will say, where did we get 1? The idea is simple. Just bring out e raised to power x out. When you multiply e raised to power x by e raised to power dx, it will give you e raised to power x, e raised to power dx. And when you multiply e raised to power x by 1, it will give you e raised to power x. That's how we have what we had here. Treasure. Okay, you already mute yourself. Let me unmute you, Treasure. Treasure, did you get this part? Hello, Treasure.
Sir, I can hear you, sir.
Did you understand this?
I can hear you, sir.
Did you understand this part?
Yes, sir.
Very good.
Yes, sir. Yes, sir.
Let me move forward. So that's what we had. Now, using Maclaurin series to expand this is so simple. Just get the ideology. You have 1. You are trying to expand only e raised to power dx. You are not expanding -1. Only e raised to power dx. Just like you're expanding e raised to power x. Using Maclaurin series, you have 1 plus dx plus. Now, this is like dx over 1 factorial over d square x over 2 factorial plus d cube x over 3 factorial and so on and so forth, minus your 1. Minus your 1. So automatically, -1 we cancel 1. Did you get that? -1 we cancel 1. Okay, let me release Bukola too. Bukola. Hello, Bukola. Bukola, are you there?
I'm answering.
Are you following?
Yes, sir, I'm following.
Bukola, you are gone. You are gone. Your voice. The noise is much there. Okay, so you are, okay, let me release Stella. I want like 2 people to follow. Stella, hello, Stella.
Yes, sir, I'm
You are following. Okay,
thing.
very good. So you have -1, we cancel
Yes,
1. When -1 cancel 1, we are left with dx squared over x, the cube x over 3 factorial. You understand this Maclaurin series? It's not a big idea. Just know that 2 factorial, 3 factorial, 4 factorial is related to binomial expansion. So now we want to apply dx. When dx comes here, and the x comes here too, it comes here, it comes here. You know that dx, that will give you what? 1. That's how we have this 1. When you remove 1 dx here, you'll be left with 1 dx. You'll be left with 1 dx over these 2 factorial. Dx already cancel 1 dx here. Now, dx cancel 1 here, you are left with 2 dx. There is meant to be x here. There is meant to be x here, guys. Did you get that part, Stella? There's meant to be x here. It's not only d. It's actually dx something.
Yes.
Did some of you notice this and correct it in your notes? But Lumi, you are just writing. That means you did not correct it. Sorry. What's her name now? I forgot. Adura. You did not correct that thing, Adura. You did not correct. Okay, so you guys have noticed now. Okay, good. So you can correct that now. So you have this as your answer. Now let dx tend to 0. If dx is not tending to 0, ladies and gentlemen, you have 1 plus 0 plus 0. How did I know? Check this place. When dx tends to 0, this will give you 0, this will give you 0. So you only have 1 left. So e raised to power x times 1 is still e raised to power x. What does that tell you? I can say proof that the y ex is equal to ex for the y. You don't understand? That is proof that when you differentiate y, when y is equal to x, the answer will still be ex, e raised to power x. You see that it's still the same thing. So if you differentiate it 10 times, it's still the same thing. Did you get that, Stella? When we differentiate e raised to power x,
Yes, sir.
we will still get the same thing. I'm just giving the communion. Now, next one is differentiation of sum. Differentiation of sum. Differentiation of sum. We want to see when this one is very easy, and this is where we are ending the class. Then I will give room to questions. Differentiation of sum is very, very interesting. We will now apply that rule that I taught you. Okay, we have many chat. Let me quickly check. I said no attendance. This is our, so I will not see people's question. It's not time for attendance. Okay, who is this? Julia, you have question? Okay, good, I'm coming. Let's allow Julia ask her question, please. I'm coming, I'm trying to, okay, Julia, Julia, okay, you can speak up. Hello, Julia.
Sir.
Good. Oh, you ask your question.
Sir, under the last example, yes, y is equals to e raised to the power of x.
How many percent? Just now I saw that phone in 1%.
I don't understand. I'm coming. Julia, let me see your face. Where is Julia now?
Sir, I'm hearing you.
Okay, good. All right, so your question.
Sir, I can hear you.
Okay, the last part.
Yes, under the fourth example.
Okay. Are we there? E raised by x, Abby?
Why? Yes. Yes.
Okay.
Yes.
All right, ask your question here.
Under before after expand e.
Okay. This one, this place, Abby. Hello, Julia.
Yes, that Maclaurin series.
Exactly. You don't understand it.
Sir.
This is what we are
Yes.
expanding. We are only, it's just like you're expanding e raised to power x. Are you getting me? What we are expanding is e raised to power dx, right? Now, the idea is the first one will give you 1. Are you getting me?
Yes, I'm getting you.
That was I said is more or less like your binomial theorem. But unlike it, this one just go in a progressive form. The next one will be that dx raised to power 1 over 1 factorial. The next one will be the x cubed square over 2 factorial. The next one will be the cube x over 3 factorial. What will be the next one, Julia?
D
raised to power what?
Raised to the power of 4x over 4 factorial.
Exactly. That's the idea that works here. Now, this is your -1, so your -1 comes there. Are you getting what I'm saying? You get the idea now?
Yeah.
I have less than 10 minutes to end this class. So I won't attend to questions. I can attend to questions on our WhatsApp group. So let me quickly do differentiation of sum. I want to end this class with this last 10 minutes. Are we together? Please bear with me. We just have to manage what we have. We only have 40 minutes. So now, look at this question now. This is plus. You have y is equal to ax raised by n plus bx raised by n minus 1 plus cx raised by n minus 2 raised by 2. Now, something like that. Just check the idea, the way it works. Just like I taught you with that formula. That formula is very, very, the nominal formula. The nominal formula will help you a long way. Check this place out. We differentiate this one only. You differentiate this one only. You differentiate this one only. Simple. And remember the rule. What is the rule? What is the rule? What is the rule? The rule says you multiply n by what is here. Are you getting me? And remove 1 from here. So let's see this example. 4x raised to power 5 plus 3x raised to power 4 plus 6x raised to power 3 plus 2. Find dy dx. Since I did not ask you to use first principle, is somebody getting me now? Since I did not ask you, who is doing this to us? Who is doing this to us? Since I did not ask you to use first principle, just apply it this way. D over dx over 4x raised to power 5, d over dx into bracket 3x raised to power 4, same thing here, same thing here. Now, when you have something like this, then when you are differentiating, check the answer out. 5 multiplied by 4 is what? 20. Remove 1 from 5, then you have 20x raised to power 4. The next one, 4 times 3, 12. Remove 1 from 4, 3. 3 times 6 is what? 18. Remove 1 from 3, 2. Any number that does not have x will turn to 0. That's why these two turn to 0. And with that, you have solved it. So it's very easy and straightforward, except you have to use first principle. Though you have examples like this, everybody should be able to fix this. Don't forget that you have to show this rule, that this is the rule you are using. So you just say, if you are differentiating this, you put it like this, put it like this, put it like this, and you have your final answer. Now let's check another example. Check this comment. Differentiation of a constant is 0. Don't forget that. Differentiation of a constant is 0. Now let's do one more example and end this class. I have very short time left. Let's do one more example. Who is doing this? Now guys, I will mute everybody again. Y is equal to 5 sine x plus, look at this place, plus 3 cos x plus 5x raised x squared. Look at this example now. Now, everybody, you can start typing in your attendance fast. We have short time. Type in your attendance now. While I continue with the class, it's time to take attendance. Now, check this. D over dx, 5 sine x. So you are differentiating each. You don't have to do them together, unlike when we are dealing with those ones. So this one is coming alone, this one is coming alone, this one is coming alone. Now, when you differentiate sine x, what does it give you? Hello guys, Stella, when we differentiate sine x, what did it give us? Hello Stella.
I'm not seeing this. Sir, I'm not seeing the screen. I'm writing my attendance.
No, just answer
Wait,
me.
let me check.
Just answer me. When you differentiate sine x, what will you have?
I don't know.
Yay, Stella. Okay, Julia, help us. What will you have? Julia, if you differentiate sine x, what will you have?
So cos x.
Cos x. That's why you have cos x. So you don't need to stress yourself and prove those things to us. Just say you have cos x and your 5 is here. If you differentiate cos x, what will you have? You will have minus sine x. So multiply it with this 3. That's how you have minus 3 sine x. Now remember this. If you differentiate this, 2 times 5 will give you what? 10. 2 minus 1. 1. That's how you have 1 raised power x. Hello, ladies and gentlemen. Did you get that part? Now, final example. Check this one out. This one is easy. X raised power 6 minus 7 x raised power 3 minus 6x plus 4. This one is very simple. Quickly check it out. So you have... Hello guys. Are you there? You have 3.
Yes.
So you have 3. You have 6. Your 6 comes here. Then you remove 1 from 6. It turns to 5. You have 3 times 7. It turns to what? 21. That's why you have minus here. Remove 1 from 3. It will be 2. This is meant to be
not
2.
4.
Not 4.
Yes.
Are you with me? It's meant to be 2, not 4. Then when you 1 times 6, we give you minus 6 because of this minus. Now x 1 minus 1 is 0. So x raised by 0 is what? Is 1. That is how you have it as minus 6. And that's why your final answer is what? 6x raised by 5 minus 21 x raised by 4 minus 6. Ladies and gentlemen, did you? Okay, I have another example. I think it's straightforward. Final example. When you differentiate cos x, what will it give you? It will give you minus sine x. So that's where your answer will not be minus 8 sine x. If you differentiate cos sine x, what will it give you? Cos x. So your final answer will be what? Minus 8 sine x plus 3 cos x. If I were you, I will now rewrite it to now become what? 3 cos x minus 8 sine x. Ladies and gentlemen, I want to, with this, say thank you very much for being part of this class. I love what we are doing together. And I don't know if some of you really appreciate this class. If you appreciate it, you can mute everybody. You can, so you can shout now.
Yes, sir. Thank you, sir.
You can ask questions. All right, so you can wait.
Sir, good night, sir.
We don't do. Hello, guys. Read this thing with me. See you next class. Remember to stay safe. Remember Nigeria and the rest of the world in your prayer. For those of you taking position, remember your opinion. Hello, you expect your assignment. Expect your
Break my
assignment
name, my
tomorrow. I will also upload this video. I already uploaded the other video. The 2 sessions we had this afternoon.
Good night.
Have you written your attendance? I already uploaded. I'm still giving instruction.
You go right now for WhatsApp. Go right now.
Don't give me attendance on WhatsApp. Don't give me attendance on WhatsApp.
After that thing,
Attendance is still coming in. Okay. So get this instruction. Get this instruction. The assignment will come in tomorrow. And tomorrow's assignment will be a bit serious. And that will form a 5-mark. That will form a full 5-mark quiz tomorrow. You can go back and watch this YouTube, watch this video on YouTube. Remember to subscribe to my YouTube channel so that you can always check and receive updates when there is a new video updated. I want to be sure some people are in class today.
Okay.
Sinu, are you in class?
Nobody. They don't have light in their house.
I'm asking questions. Sinu, are you in class? I'm not sure Sinu is in class. Praise, are you around? Hello, Praise. Is Praise in class? Praise is not in class. All right, attendance has come to an end, Abby. We have next class on Monday on Felili. Next class is on Monday on Felili. You said what? There's no data. You can reach out to that lady and get data from her. Her data are cheap. Ladies and gentlemen, enjoy your weekend and remember to pray for Nigeria. I love you all and God bless you. You can leave the class now.